Hello friends, welcome to the part 2 of the game trainer development using C# video series. So last week we discussed the static pointer. So this is we left off from the last week. So if you increase this value, you will get the value. So we stopped discussion of dynamic pointers. So we are going to start today from these dynamic values and the pointers. So before we get the pointer, so let's get this progress bar value. So in order to do that, I'm going to start this is a 32-bit integer, so I'm going to start with a 4 byte, and I don't know the initial exact value, and I do the first scan and I refresh the progress bar, and now I can see this progress bar is increased. So I go for increased value and I go to next scan, and I can see the couple of variables here and lots of variables, or rather. So you can see these addresses are noted in black. That means those are dynamic. Those address locations are dynamic. Rather, we can say the result of a dynamic pointer. We'll discuss that. So again, I refresh. Now I can see the decreased variable. So I'm going to check for decreased value, and I click next. I can see a couple of again, and I refresh this one again. So I can see an increment. Okay. All right. Okay, I can still see the couple of. So I'm going for. All right. I can see now. I can see this 111. I think the value with one variable, the variable value is 1 is the actual one. So let's do a unchanged value because I didn't click anything here. Okay, I also have now. Let's go for refresh. Okay, I have increased value and I go for next. So I think this 76 is a good candidate here. Well, let's see. I'm going to refresh this one again. Okay, I got decreased value, and I'm going to refresh one again, and so I think these are the values. You see, we cannot say exactly what's this. So I'm going for these values. I think these have you see these values. All right, now we have a bunch of values that are candidate values. So you have to do multiple scans in order to find the values, as I stated earlier also. So these values, we have 1, 2, 3, 4, 5. We have 5 candidates memory locations. So let's see what is the correct one. All right. Okay, see, this gets changed. All right, now I don't think this is the correct one. Okay, so I can eliminate this. So we end up with these 4. Let's see what we can do. All right, so you can see everything changes, and I do believe this one neither, so I can remove that one because I saw some garbage value putting it here. So that was 22EABC. So okay, since it refreshed to 81, I'm going to play around with these couple of variables here. Let's say 82 here. Okay, nothing happens in the progress bar. Let's see this one. Okay. All right, this is final one. This is the variable that we are going for. So I'm going to remove everything, and I leave this one. So if I set it to 1, all right, you can see this is the variable that we are interested in. But there is a problem. If we close, now we know this variable, right? Now if we click this button, you will get the value refreshed. So if I refresh, see, I got the values. All right, now what happened? Now this value, this INC static is it tests them. So now I'm going to save this, and I'm close, yes, and I close this window, and you see that my everything get question mark, which means I don't have the address locations because I closed the program. So I'm going to open that one again, and I attach to the process. This is the main, okay, and I say yes. All right, you can see there is a value here. There is value assigned here, but can you think that's the value here is 3, but can you think that 3 can possibly fit here? So this progress bar is from 0 to 100. 3 lies here somewhere here, but this is like, more than 50%. So if I refresh, this value won't get changed. That is because now this memory location refers to something else. Also with the progress bar, that memory locations also refer to something else. So the value now this value the progress bar, the memory location now change. Now it refers to difference value. So let's find out what is it. I'm going to leave this one here so we can compare the addresses. So I'm going to use a new scan, brand new scan. It's 4 byte and I don't know the initial values. Okay, I'm here since I can see, so I am going for bigger than 50. Alright, so now it's bigger than 50 and I refresh, and now it's lesser than 50, and obviously it is greater than 0, so I can filter out some values. So let me reduce this click rate. I thought it would help, but it seems it won't do any help. So let's go for 100 milliseconds now. Update details. Okay, and definitely this is smaller than 100. So I'm going to filter out some values so we can pinpoint some values. See, without clicking any any refreshing, so I was able to pin down some locations. So now you can see a changed value, so I'm going to select the unchanged. That is because I didn't click any. So I'm going for next scan. So I believe this 42 42 42 is what I'm looking for. So let's add those 4. Again we have 4, and I believe this last one earlier also we got the last address. Let's see if we go for last address here also. Alright, the last address is the one. Okay, so this is the address we are having right now. This is our previous address. As you can see, the previous address is 002F9A90, whereas this one is 003050E0. So what is going on here? This is a thing that we are going to discuss today. So as you can see, this one remains the same, right? So you can see this. That is because as we also mentioned earlier, this is a static variable, whereas this is a dynamic variable. So in dynamic variable, the sense is like this. When you are using Java or any other programming language, say for C++, if you are creating a object from a class, or in C++, if you create a object from basic, let's say in point or something, create allocate memory, the memory allocation is dynamic. So we don't know where the malloc function allocates our memory, and the allocated memory, the memory location is handed over to the pointer. All right. So allocated memory location address is dynamic. So let me explain this by the concept called stack and heap. So I'm going for paint program. All right. So here, let me divide this into 2. Let me get some higher brush here with the high stroke. Okay. Oops. Okay, let's divide this into 2. Alright, this is my stack. So I put this here. This is my heap. This is my heap. So okay, all the memory that we declare here is all the variables are reside in this stack. All the object or mallocs, memory allocated dynamic memory locations, or let's say the dynamic memory allocated memory locations are listed here. So here, okay, we have them up. All right, now let's get this one. Let's focus on this static memory location. So we have 0, 1, 3. All right, we have, let's use this one there. 0, 1, 3, 0, 6, 3, F0. So this is my static variable here. Okay. So it has the value of 3. Alright, now I can set this one here. Right, this is equals to 3. This is my stack. But let's discuss this variable. This. Alright. 0, 0, 3, 0, 5, 0 is 0. Now, here, this variable is in heap. 0, 0, let me get the value for you. Can I copy this? Oops, that's XML. So I cannot copy straightforwardly. So, okay, I can copy like this. So this is now equals to 1. Alright. So this is the basic memory address that we have. Now this value is in heap. But there is a pointer, so this value points to something else here. This value points something else, something here in these memory locations, and we need to find this one. What is this? That is what we are going to do right now. If we find this question mark, the value of this question mark, then that value, that memory location is static always. So when you do C, okay, let's get the C. Let's discuss with this using C language. So this is like your pointer, and this is like your memory allocated address, malloc address. So you have int star x, and you have the semicolon, and in the main method or some other method you say x is equals to void int star malloc size of int into 1. So that malloc, the result of the malloc is this one, and your int star x is this one. Int star x is also a memory address which holds the pointer. Alright, so now let's get this pointer value. So let's get this int star x value. For simplicity, let's see, this is int star x. So let's get this int star x. So as you see, int star x is the one you declare when you write your C program. So that address won't change. The compiler allocate a 4-byte space for that pointer, the memory address of this pointer, because this is a 32-bit pointer, so 4 bytes. So compiler allocates that 4-byte memory for that pointer. So basically in programming, so the it's like this. You have your pointer here. So you got pointer, which is 4 bytes. Let's say 32-bit. So pointer has value, let's say 0x00, F0, 1, 2, something like that. Okay, let's see, this is 32 bit, so we get 1 2 3, okay, another 2 3 7. All right, so I have 4 bytes, 1 2 3 4, 4 bytes. So this is the pointer, and after the malloc instruction you have this. After malloc, this one has the value of another memory location. So this is dynamic memory allocated memory, which is somewhere in the 0x1004FF20 1 2 3 4. Right, this is the allocated address. So when you go here, when you get the content, you get the value. The value will be, let's say, 4. So in hexadecimal it will be 0x04. So let's discuss everything in hexadecimal so we don't have any mismatches here. So this is the variable that you declare, the pointer variable, and when runtime, the malloc instruction allocate memory. So allocated memory address is this one. So this address assigned to here, and if you and inside this you have content of value 4. Now we have this one. So here this is one. We have this. Let's go to, and we have this one also. This allocated memory address is this one. 030003050 and let's find out this one. So how do we gonna do that? It's simple, and if you follow the cheat engine tutorial, they also teach you how to scan the pointers. So you can do 2 ways. You can just either by right click this one and go for scan pointer scan for this address, but since we are going on basics and we are covering everything, let's do this manually. So I will discuss how to scan this memory location manually, right? So with this value in this address bar list, I'm going to double click this one and I copy this address. So why I copy this address? That is because I want to find what memory location has this memory address. So what memory location has this address? Now here our address is this one and we don't know this one, so we need to find this one. So therefore we are going reverse. So we have value in program, we have variable, dynamically allocated memory address and value. Now we are going value, dynamically allocated address, and from that declared variable. So here we have the value and the dynamically allocated memory address, and from that we are going to the actual variable declaration pointer memory location. So therefore we need to find what memory address, what memory location holds this value. All right, so I'm going for I'm starting from where I am going for new scan, and for this I click the hex button because these values are in hex. I'm going to copy this value, all right, and I'm going to paste this. Okay, and I can see there is a static error, but there is another way to do it. All right, so let's forget this everything. Let's forget everything. Now, if this variable has to is changed, if this variable change, that means something inside this program change its variable. So the program instruction change the value, which means the program instruction gets the pointer value, and from that pointer it changes the content of the pointer. So the method I showed you does not work for every search. I will show you why in later. So what instruction change the contents of this variable? So I'm going to right click this one and I click find what writes to this address. You can use the F6 if you want to, and it's asked for attach debugger, yes, and click yes. All right, now if I do this, you can see content of the ESI. All right, content of the ESI is the pointer value, the pointer. So we always say that content of the ESI is this one. So the ESI may have this value. All right, so in our case ESI should have this value. So let's see. So if I double click this one, so the ESI value has, sorry, okay, 003050 is 0, the same as this one, and the guest memory location is also set as this one. So this is the value that we are going to, the value that that's shown seen in here is the one that we have to follow. Okay, right now I'm going to copy this one and stop this and say, put the hex on and paste this, and I use the first scan. So you can see there is a static memory address. All right, so this is the only one, and I can see this is the only point address that we have. So I'm going to double click and go for this one. But if you go for this one, you only see the memory location that it holds. So we have a candidate pointer. So we have a possible candidate pointer. So it seems that this one holds the address of this one. This is first one, holds the address of this one, the allocated memory, and it has the value of 73 in this case. All right. So it seems that we found this. But in cheat engine, how do we go from pointer? Simply, you copy this value. Alright, you double click this and you copy this value and click this pointer button. Oops. And you paste this one. Okay, don't worry about this offset here. Just for now, ignore the offset. Offset also have to something to do with the fact that the previous method I showed you when scanning this memory by putting this value directly to this one, that won't work. Also has something to do with offset, and that offset also has something to do with the classes and objects. So we'll discuss the classes and object in the details in next video while writing a programs using C++ and compile those and get the idea of how these classes and objects are interacting in the assembly language, because you know assembly is not a object oriented programming language. It does not know what is object, what is class, and what is polymorphism, override, overload, everything. It doesn't know. It does not inheritance, right? So don't worry about this offset. So you can see this value. Let me show as decimal. So you have this pointer. It's pointed to this base pointer. So this one pointed to this. So this point to this one, and it points to this memory address. Okay, so the value. So if I change this, you can see this one changed. So let's see whether this one is actually a memory pointer or not. All right. Okay. So let's close this one. All right. And let me minimize this one in order to get the our program. So this is our program. Let me double click. Okay. Open the process. Yes, I can. All right. You can see there are these variables have no longer values in it, and we have a static variable as expected its work. Notice this one. This one has a value of 96. As you can see that it is roughly equals to this progress path value. So let me set to 0. You can see now it is setting to 0. So now we found the pointer. So this is our int star x declaration variable. So when we execute x equals malloc int star or size of x into 1, so it memory allocates memory location dynamically and it assigns to this one. So now it is 3DE904 and it has value of 0. The new memory pointer has the value of 0. Alright, so each time I close this one and open it back again, and if I attach the process, you can see that memory location won't change at all. So you can see you have the pointer. Now you have the base pointer, and from that pointer you have the allocated memory address, and from this allocated memory address you have the value. So now we have this one. Now we found this one. This is the one we want. So this was if your program doesn't have received any update, this memory pointer remains the same. So if they patched or released an update, this memory pointer may get changed, because if they introduce some other memory, some other variables in their development process, so this value may get changed. So right now I'm going to delete these two addresses, so they are no longer necessary. So I have these two, and I'm going to save this one. So I have a clean file. But notice there is a problem. Alright, there is a problem. In games, these pointers are not easy as this. There will be multiple pointers. There will be ample amount of pointers you have to get through. For example, let's discuss when I doing GTA San Andreas couple of years back, I found that the player's XYZ position is a pointer to player's pointer. Alright, and the player pointers has another pointer for the player's current car. Alright, so in games there will be many pointers, so pointer to pointer to pointer to pointer. So it's like you have your, it's like this. So let's see, so oops, so you have your car object, and let me get my notepad. So you have int star, so let's see, you have player object here, p, and you have p equals new player, and you got p dot car equals a new car, and this p car health. So this will be your pointer to value. This is your pointer to pointer, and this is your value, like this. And also you have your p x location. So this is your xyz location. It's also a new location. So you have this pointer x. Alright, pointer to a pointer, right? So usually games like this, you have a pointer, you have base player's pointer. So since the games are also object oriented, they use some base class, or maybe they have a base class called human, and the player extends from that human class, and that player has all the attributes from the human, and he has also XYZ location. So, and the player has also have health. Like that, they have So maybe player also have a health here. So P health is equals to 100. So this is just pointer and a variable. So this is pointer and this is the variable. So this pointer, this is also pointer and this is the variable. So in games like the most of the games they have multiple pointers. Alright? Okay, so let's discuss multiple pointers right now. Okay, now I'm going to delete everything here. Okay. So here I'm going to cancel this. Now let's discuss the multiple pointers. So multiple level pointers rather we can say. So this one, these two buttons do the same thing. Now you have this value increasing. Earlier we had this one. All right, you can see this. Now you have this. These two buttons do the same thing but in different ways. But let's see how to find this one. Let's see whether this is a single point or multiple point. Alright, now this is simply, you can see the value, this is simple to scan. So I'm just going for the value 8 here. So this is, I put 8 here and I start a new scan. And I put 9, I have a next one, again 10, okay I have two values here. Both are increased and I believe one is for updating purposes, other is for actual pointer, and I believe this is not the one that I need because I see some values. You see, when I move the mouse, it gets some other values. So this is the value that I require. Alright. So remember, finding memory locations in this program is easy because this is simple program, but in games also this is bit difficult. You need to do multiple scans. So in here, when I move the mouse, I believe the on paint method or something on mouse move is doing something to this label here. So it leads to get this memory location, the value of this memory location changed, and this one resides in the managed heap. So this is C++, the .NET part of this one. This is the native C++ part. So since most of the games are developed in C++, the native languages, so this is the one we are going to use. So if I int to 1, alright, this one set to 1. Okay, if I increase this one, I get everything updated. Alright. Okay. Now let's see how to find the pointer. So here I'm going to do the shortcut method. So I'm just going to put this one in the hex value. Okay, I'm going to paste this one. Oops. Alright, I have memory address. Notice that this one is not green. That means this one is also dynamic. So if we get our paint back here, so let me get a new one. We have the final destination here like this. So this is our final destination, and from that we found let me get the correct one. So we found something like this, and that one resides here. And also it seems that this one also refers to something else. Okay, so it is this one. So let's find this one. Okay, so you have this memory location 00 final. Let me get this one. So if I double click this one, and if I click it as pointer, so if I paste this, you can see we have the value. Alright, so show as decimal. So I have this value. So if I get this program back, so if I increase this, you can see I can influence the value. Let me change this one. Yeah. But if I close this program and I get open these values again, this one also lost because this is also a dynamic pointer. So this one also have a back one like this. So let's do as we did earlier. We copy this one and we paste this one. Now we are having a problem. We don't have anything, any blockade, any location that contains this value. Now, what's going on here? Now, this in this program there should be a memory location, right? So some memory location should hold this value, but here we cannot see the value. Now, why is that? So that's why I told you this method won't work every time. Alright, so we have to use the instruction method. Okay, so this pointer has another pointer as we found it because that's also a dynamic pointer. Now let's see, find what writes to this pointer. Okay, let's see, find out what this pointer. Let's see what happens. You see nothing happens. Alright, that is because no one is writing to this pointer. If somebody is writing to this pointer itself gets changed. But in order to check that, so if somebody maybe can read from this pointer, so we use the find what access to this pointer. Okay, alright, so I already have some values and it get refreshing. So this is count means this instruction execute on this pointer multiple times. So if I so as you can see, if I click this button, you see that this one is increased. Okay, so somebody is reading from this pointer and somebody is writing that pointer. Before writing, you read the pointer and get the value. Alright, so let's have a look on both of these instructions. Let's check whether they are points to same memory location. Okay, same memory value. Alright, you can see, oops, not this is. So if you double click this one, you see that there is a ECX plus 4. Alright, before we go any further, let's see the value of ECX. ECX is our 05979B0, and also here EAX is 05979B0. So these both addresses are same. Alright. So now you can see there is a plus 4 here. Now what is this plus 4 means? Now this is, we are going to discuss this concept in detail. This has something to do with, in C language, this has something to do with structures in C++. So I developed this one in C++. This has something to do with classes. Okay. So this variable resides in a class. So this one is this variable is in the class. So what is 04 means? So the C++ class like this. So this is not C++ coding. So this is pseudocode class. So the pseudocode class like this. So I have variable and object. So this is my class. So I have variable, let's say var1 and var2. I have bunch of variables, and notice these variables. All right, these variables have memory locations. So the compiler allocates memory locations for the classes. So if you create a object of the class, so that memory allocator, so malloc operator will also allocate that amount of memory to the class also, right? So if I displace, say, var, so I declare the end of the class here in class pseudocode. So this is my runtime here, var c1 equals new x1. So the c1 have the memory, the new memory operator allocates the bytes for this one and this one also. So let me open, all right, not now. So let's assume this one is an integer and this one is something else. Say a void pointer here, we can have void pointer. So void pointer, now in pointer in C++ is always, in 32-bit machine is always 4 bytes, alright? So it's allocate 4 byte here and 4 byte here. When I develop this class, this class is like this. So I have one and I have another pointer to this class. So let me change this one. X1 is var2, alright? So I have a pointer here and I have a pointer here and I have a integer variable. Now let's go back to our program here. You see, when we scan this variable, it directly had a memory location. Alright, so we had a memory location, but when we scan this right now, it did not have the memory location. That is because when the compiler compiles, it generates the assembly codes like this. Okay, so here your first variable is this int variable, right? So these class are ignored by the compiler. It won't ignore, but the class does not have a assembly instruction. Okay, so when it allocate the memory, so it first allocate memory to this one and this one. All right. So since our first memory variable in this case is this int one, it is the one that assembly instruction allocates memory for as the base 0. If we take our memory, let's draw our memory here. So you have our memory, we have our memory like this. This is our memory. So when our new memory allocator, so new object malloc allocates memory, it allocates 4 bytes here. That is for this is 4 bytes for variable xint. I will x. I believe this is the x here. I put, so this is var1, this is var1. 4 bytes int var1. So here in memory you have 4 bytes and another 4 bytes another one. This is x1 star var2. This is another 4 byte. Alright. So this is how the memory allocator, so the malloc operator allocates memory for this class. So now when it allocates, so this assume this is the allocated address. So this has also memory address. So we should have memory address. So let's say the memory address of this one. So I keep get the wrong arrowhead here. So let's say this one has the address, let's say 0x0000. It should be a 32-bit, right? So 32-bit pointer now. So I have 4 by 1, 2, 3, and I have another 4. So this is a superficial address. No, nothing gets allocated in 000 address. So this is 0, right? So if we go further down, we find this variable, right? So now what is with this one to do with our this one, right? Now you see, when we discussing when we get this one, if we scan this address, let's scan this one again. Oops, okay, I forgot to put the hex value. You see, I find this one. That is because this value is the one, this is the memory location that this one has. Let's input that one so we can get that easy. Alright. This is what this memory location has. So this is the memory location this value has. Now when we scan this memory location, we get another memory location, the memory address that this one holds, okay, to another memory location that is this one. Alright, this address, this one. So we have this one, but it doesn't have any memory address. So in memory, the allocation looks like this. So we have this class, and I assign this, and since I developed this, I know this variable is also there, alright? But here, this variable does not have a direct memory location. That is because this reason. So I have another memory location. So let's draw another class here. Another 4 byte addresses. So I have 4 bytes of int var, 4 bytes for int var 1, and another 4 bytes for int var 2, 4 bytes for x1 star var 2. Alright. So what's going on here? Actually, this memory address is connected to this one. Oops, let me get the brush. This memory address is connected to this one. So this one is a pointer, and this is pointer, and it has this value. So we have a pointer, malloc operator, allocated pointer, and the value. But the new memory allocator, so the memory allocation allocates first 4 bytes to this one. So let's see, this is x. Let's assume this is x, and the x, this one is x plus 4. This one is x plus 4, this is x. So when we check this one, this is the result that we received right here. Okay. This is the result Okay, this is this memory location that we received here. So this is this one. So if I put this one in, so I input to this one. This is our memory location. So let me put this under. This one has this one and this one has a value. But if we check for memory which hold this address, then we cannot find anything because it's not the first variable. That is because no one is gonna hold this address like this because we have another variable here. Okay, so if our class has only this one, then we definitely have this one, search for another one, then we have the value. But since I programmed this, I did such a way that we have an int variable and a pointer to that class. Sorry. So this int variable is the one that holds the value for our text box and progress bar. This one also has the same class, same object, but it also has the int variable, even though we don't use it, but it allocates some memory. Okay. So we'll discuss the classes and objects in deeper in next video. So we discuss how variable gets compiled in to the class and how the assembly instructions generated there and what happened to how multiple classes have multiple variables and how the function increment these. So for example, I have two classes, let's say class A, class B. So I have class A has an age of 5 and class B has an age of 10. If I increase the value in class A, it increase 5 to 6 and not the 10 to 11 in class B won't affect it. So let's discuss those in deeper by doing actual programming in next video. So for this, let's get glance over. Now here we have this integer variable. The same object is here created in this one. Same integer variable here, same pointer also there. But this variable, no one holds this one. That is because the memory allocation pointer holds this address to some other memory location. That is what we see in this one. ECX plus 04. So if I double click this one, so you will see ECX plus 04. So the ECX is the x value here and plus 04 is the actual pointer that points us to here. So the memory location of individual variables won't store in the memory location, rather the 0th index of the structure. So these offsets act as the variables to our individual class. So you have, let's say you have 10 variables. These individual variables are accessed as offsets in the base class. So always the base class, the base address of the class is the one stored in memory locations. So in first one, we see our variable integer stored in the memory location, but it's not the integer variable itself. The thing is, the integer variable is the base of the class. That's why we saw that memory location is held by some other memory location. But in this case, it does not, because this variable is the second variable of the class. So the compiler allocates first 4 bytes to the int variable and the second 4 bytes to the this pointer. So in this case, the base address is resides in ECX register, this one, and the plus 4 is the pointer. So the pointer, that pointer accessed. So now we need to find this base address. So that's why this method is most efficient and most surely worked with. So I'm going to copy this address and I close everything, and instead of this address I put this address. Now let's do a scan. you see this address is also a dynamic address and we have a memory location. Okay, so what I'm going to do is I double click this one. Okay, let me get this one first, copy this value, and let me delete this one, and I add another offset. Okay, so this time I replace this value, but this value we should have a offset of 4 because this is our base, and if we go over here, this is our first int variable. So this is not what we want. So I'm going for another 4 bytes below. So I add 4 bytes. So in that 4 byte, I have this one points to this address, and we have the value. As you can see, I have another pointer. So this one points. So in that content I go 4 below, I have another pointer, and that pointer is the base one, that is the variable of the integer variable, and that has this value. Alright, so if I click another one, 4, it is 0, that means this the last value. So if let me get this one here. So if I double click it, if I add another 4, now it won't point to this address, it points to this one. So, but this is null. Since this is null, it shows 0. So this is, so oops. So this is 0. So it's null pointer, right? So this one is now it's point to here. So let me reverse it back. Right. So as you can see, this address is also another dynamic address. Okay. So it's like now this. So let me draw here quickly. So I have 2 of these 2, and it seems that I have another 3 here. So let me divide these. Alright, so I have this intx. So this is 38. So this is hexadecimal, this is decimal. Okay, don't worry about that. So this is my final. This is 5979B0. I just use 5979B0. So this is 00. This is the 5979B4, the pointer. So that points to here. Let me get the brush. That points to this address, this base address. Okay. So let me get the other one also. This is 005979 C4. This is right now has the null value. Okay, so this is null value. So this point to here. Now somebody here should points to this one. So we have to find this base. So by adding 4, we get this one and go right there, adding 4 like this one. So like that, we should get these addresses until we get the green address from here. So we have this address, right? Okay, so if I add here, now this seems to be our address here. But since this one is lots easier than a game, we can guess the base address of this one also. So it should be A0 here. Let's see. So this we get the pointer right now here. Okay, and so let's see who have this, whether this one has a value. Okay, we have no value here. So if we access access to this pointer, alright, so let's increase, and we have ECX plus 4. Okay, so if we stop this, I believe I added wrong one earlier. So you can see 00597980. As we guessed, this is 597984, so this minus 4 is 597980. So this one is its base, 0 is its base. So we have to find the base address. Until we get the green one, we have to hunt down the address. Okay, so now it seems, let's see, let's search that one also. So 5989 is 0, right? So this is the address that we, okay. Let's reduce the 4 value. So let's reduce 4, it's going to be 0. Okay, you can see another variable, and so 597994. So if I add another offset, 597994, 5979, this is 94. Okay, and we have to add offset from that 4. We have a base address. From base address, we have another one, right? So here, if we get done this one we have to add 4. That is correct. And we get this one also we have to add 4. So I add 4, and we get this one we have the value. So you can see we have the value. Alright. So now I'm going to add search memory addresses until I get the green address. So in order to do that, I delete everything except this address. So here I am going to do the same process once again. Point. I have to put the point. I think I miss. So I have to, I have to access this point. I have to always use this. So I have this one. So next time I'm going to use this one. So I know, see, offset you always 4. So stop this. Get this, copy, search here, 84. I say fire, another offset. So 597984. So I have 90, I have for this one, and I have for that second one. So again from that I have for final one, I have this one, right? Alright, so find what again, new scan, find what access to this address, find what access to the pointer. Okay, I have the pointer. Let's stop this one, copy the value, and search here. I get 74. Add the point offset again. 7974. This is 7. So I have the value, no change in value. So stop here. 74. Access to this pointer. Okay, this is the one. Oops. 7970. Copy, close everything, paste. Paste this one. 64. I add 5979 at the offset. It's going to be 4, 597964. Again, I have the value. What is going to access this pointer? Stop. 7960. Copy that one. 54. You're going to add another offset. It's going to be 54 and 58 here. And find what access to this pointer. Again, stop. 5050. 7950 rather. So it's this 44. Just gonna add 4, add another offset, add 4, and this is 4. Still I don't have a green address, so I'm just going to dig, go deep. And remember, if you found multiple addresses like this one, usually in the green section, the cheat engines tutorials recommends you to get the least value address. So I believe the reason is that that is the place where you declare the variable. So the compiler insert the first memory bytes for that address in that section. So let's continue our searching, right? So I have this one. Now it's 44. Okay, I already have the 44. Right, I believe it's going to be what access to pointer, stop. So it's 40. 34. I'm going to add 34 here. Add another offset. 34. Again, value is same. So access pointers. Good organ 30. Now 24. So we have some multiple levels now. I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pointers. Okay, find what access. 20. So you can see the pattern here. Oops, I believe I didn't copy that one, but I don't know. I know what is the address is going to be. Just I'm going to type this for 0059 7920. So let's scan that one. Okay, now since I can see the pattern here, I'm just going for manual address entry now. So this is 14. I'm going for 10. Okay, I have a static address and a dynamic address. So this may be seen as a static address. Okay, but let's see. So by comparing the other variables, I can see this as a static 40. So this one is 3038. Sorry, F8, F0, F8, and this can be FC. But I believe this is the static address that I'm going to look for. So I'm just going for basic. So here I'm going to add another offset. So this is 10. I found 14. So 10 has the address of 04. 0 6, another 4 here, 3 FC. Okay, let's see how many pointers. 1 2 3 4 6 7 8 9 10 11 11 pointers, and this final 12th one is the value. Okay, right. So what happened if we go further in this one? I don't know, I didn't check it. So basically, so we found the static address here. So multiple static address, if they have multiple static address with the multiple values, get the lowest one. So I think this is our static address. So this is one our static address. So this is F8. I wonder what this address can be. So we could check for this one. Let's see what happens. So this is also a point, so if we scan this, so if we -4, so no, I think it's maybe in the managed heap, so I cannot see anything. So if I find what access to this address, I don't see anything. Okay, no one access, right? So since no instructions access this one, I believe our final pointer is this. So if we say find what access to this pointer, so you can see this is our base, right? So this is the base address of this value. So this is the base. So from that we have a pointer, in that also we have pointer, that also have pointer, and also a pointer, and that after that this is the value. Okay. So this is the example of a multiple pointer value. So now let me get rid of the unwanted stuff here. So let me have this one here. So I'm going to save this. Alright, so I'm going to close this and I reopen. Let's see whether those values are survived. Okay, I'm just going for yes. Okay, looks like we have a problem. Why we have problem? I assume you know the problem is, that is because when I am entering the static addresses, I enter the static address by hand. Last week we discussed the issue of by entering the static addresses in the hand. So this one is no longer points to the address that we found. Okay, but these two, the reference to the base module address. So this one does not refer as the base. This is written as the absolute one. So absolute ones are not working here. So the DMA, dynamic memory allocation, changes its memory location each time this program executes. So this base is now going to be a problem. So in order to correct that, so in this case, I can get the static address by, I can do a search again and again until I go for a green one and I double click the green one and get the module address. But since this example is easy, so since this easy program, I can guess the base address. So base address and the offset. So this is our first one. So that is 163F0. So let's copy this, and if I paste this, I have no pointer because that is a static address. So if I go 4, no, and 8, also no. So what if we get C? Alright. So we have 0, 8. So 8 plus 8 is, so F8, F9, F8, FB, FC. Okay, another 4. So if we get another 4, we end up with this. So we have F0, so F0, this is F8, and I believe F4 is allocated to something else. And so this will be our F8, and F9 is the offset 1, and A, B, C. So that's another offset value of 4. So let's change the value of this one. Let's say 99. You can see this value gets 99. So no matter how you close and open this, until you receive a update or patch from this program, this value remains same, right? So that is going to be the end of today's video. I hope you enjoyed this. So this one is too much geeky stuff, this video. So next video also be some geeky video, because we are going to discuss how the variables and functions in object-oriented programs are stored in the assembly level, so we can get the idea. After that video, we are going to discuss the write process memory and read process memory address routines, and after that we are going to the actual trainer development. So this stuff is necessary. If we jump to the trainer from the first video itself, you won't get any idea. Believe me, it's like going to be a Greek for you. So I'm going to make it simple. I'm going to break down to small chunks that you can understand. So I know this video is somewhat advanced, so if you have any questions, if you don't get anything, if you have any clear or gray area, please post your questions in the comment section, and I promise you I will answer those questions, individual questions, because I want you to get this idea very correct, and it should be crystal clear. So otherwise you frustrated why this thing won't work. So please do post questions in the comment section, and I will promise you I will answer every single question, and by sending you an email or by in the comment section I will explain each and everything the questions you have. So please, if you have any questions, please put it in the comment section. So that's all for today's video. So I hope you enjoy this lengthy video. So I invite you to subscribe to my channel. If you like this video, click the like button and give me a thumbs up. And once after you subscribe to the channel, make sure to click the bell icon, so you will be notified when I upload a new video in this series or any video. Okay, so make sure to subscribe and click the bell icon. So I rather recommend you click the bell icon, so you can also continue on this series and get updated. Until then, have a nice week, and I hope you enjoy the video, though it's lengthy. And thank you very much, and thanks for watching.